So I want to talk very quickly about databases, and Mark's going to talk about something a wee bit similar. I'll start off by saying I'm not an expert by any stretch of the imagination. When it was computing and information systems, I was in the computing camp and never taught information systems. So I was very indebted to colleagues who'd helped me through that, and for all the people who shared on CompEdNet and on Slack and on Glow, tasks that maybe looked a wee bit like this. Relational databases, useful data, tasks that I could use. But as I got used to using these and started to grow a wee bit in confidence, I also started to question, why are we using such small databases? Why have I got a database with 8 records? Surely we should be looking for something a bit more relevant, a bit more engaging. And much as I really hope Sopoline and Whoopi are getting on okay, that really isn't authentic, genuine data that I want to analyse and extracting meaning from. So I set out with the task of trying to find some open data, big data, real authentic data, and make sure that I wasn't just giving my kids databases to type into. I found a really nice site called Kaggle, kaggle.com. And from that, I've used that a lot with advanced hires where they've taken data to use in their projects. I've used it for higher programming with file handling, so getting CSV files that they read into their programs. And then I've used it a lot for databases. The one, 2 things I've found maybe to the drawbacks is you really need to clean the data. Sometimes there can be extra commas, speech marks, things that accented characters that just stop your data going into the database and working properly. And sometimes the files are quite big, which is good because I want large data sets, but trying to convert them into SQL, I've run into some problems. So I'm going to talk you through the process of going to Kaggle, finding a data set and making up some tasks for your classes. First of all, try and think of some data you need to find. So YouTube videos, the top YouTube videos, Amazon products, FIFA player stats, Netflix movies, Spotify tracks. I'm going to go with Spotify. And if you search for Spotify on Kaggle, you would get about 90 different data sets. Some of them really small, just the top 50. Some of them much bigger. Data sets over 160,000 tracks. I chose this one to work on because it was a nice in-between medium-sized one. Not too small, but enough to make it useful. And it also had some interesting data alongside the name and artists. Once I had the data file, I wanted to get it into SQL. So a bunch of create and insert statements. There's different sites that allow you to either use the file and translate it direct. And I had mixed success with them. Sometimes it works, sometimes it doesn't. But Code Beautify seemed to do the job for me. If I could just copy and paste in the raw CSV code, just you can see the text with the commas separating them, give the table a name, and then hit the insert button. It produces this code over on the right-hand side. So that is enough to make and populate your database. Once you've got the create and insert, then I looked for a non-line database management tool. I used dbfiddle to begin with. I found that it started to slow down when my databases were bigger. So I started to use Riplet as well. And Tony told me about Oracle, how she uses that. So I'm going to investigate that and see if that might be better than both of them. This kind of came into its own during lockdown when I was able to set tasks that could be run just in a browser, on iPads, on Chromebooks, on Macs, on PCs, just any browser window. They didn't need to install software. You weren't tied to Windows or Access. So I really liked dbfiddle during lockdown. When you have dbfiddle, you can still see the code over the left-hand side. You type in a wee query on the right-hand side and you get your results down below. When you save this, just completely free, you get a URL that you can share with your pupils and your classes and connect to homework exercises and so on. On Riplet, it seems to, I'm not an expert in this, so Mark might tell us more, but there's, you know, for the 2,000 songs, you end up at over 26,000 lines of code. Type your way down the bottom, and then you see 2,000 songs and all the details scrolling up. And I think that gives you a real sense of it's a big database, big in comparison to maybe some of the small ones I'd been using before. And then you see, well, I'll need to SQL in order to get what I need out of this big mass of data. Once I've got an online database, then I try and think, well, what questions can I ask? Trying to design or write a query, given queries that deliberately don't work and pupils have to debug and find the error, or given queries that do work and having to describe the output or the purpose of the query. And I've used that in class. I've used it during lockdown. I've now been able to use it with homework exercises or for coursework preparation to prepare outside of class. If you've got the data all in there, you can just, in the white, you could just produce some of those questions and produce National 5 style responses. Once you get into higher, you can include wildcards and aggregate functions and get slightly more complicated ones. And once you're in advanced higher, then still with the same databases, or ideally more complicated ones with relational databases, multiple tables, then you can use the new commands that we need to use if we're answering advanced higher questions. The in, not, between, any exists. And once I've worked out what any and exists do, then I'll start to make questions about them. I also found a really interesting site that lets you open up or connect with your Spotify account, look inside a playlist, and give you extra detail about those songs, the genre that's in, everything about the beats per minute and energy. So that leads on to kind of interesting discussions with the pupils about how your daily mix comes up, how Amazon suggests items you might want to buy, how Netflix emails you suggestions for new series and films that you might want to watch. So you get into basics, I suppose, of some data science and how the algorithms powering these systems are making suggestions for us. I'll put in a couple of links at the end of this presentation to the original data set, so you can have a look at dbfiddle or the riplet versions and see which ones you like, and for that kind of interesting site if you've got your own Spotify account. I created another couple of online databases, one with thousands of TV shows, one with a more complicated Spotify list, including playlists, so it's got relational ones, you could practice all your joins on it. And as I was preparing this, found some interesting kind of wee revision tutorials and a site that someone suggested for if you do have to make up and populate data, you can use Mockaroo to do that. So I've gone quite fast. Sorry, just one more slide. The other sources where you might get some data, in the National Records of Scotland, you can find out all the baby names that have been given to babies every year for the last several years. So my pupils have enjoyed that in the past, searching for their own names and seeing how many babies there have been, and finding the most popular and least popular names. There's the Met Office, you can get lots of information about temperatures and rainfall. So we were able to prove with my colleague from Dundee that it is actually sunnier in the East Coast than in the West Coast. Inside Airbnb gives you a lovely visual view of the amount of Airbnb properties in Edinburgh, but you can then extract that and you can see the SQL databases behind it. So there's lots of other data that maybe your classes might like to get their teeth into. As I said, that was a wee bit fast. So this presentation, hopefully you can access this online with that short URL or by scanning that